Soil. Soil is one of the most important natural resources. It forms the uppermost layer of the Earth's crust. It is a mixture of rocks, minerals, dead and decaying plants and animals. It supports the growth of plants by holding the root firmly and supplying water and nutrients. Soil is essential for agriculture and shelter for all. Soil is thus an inseparable part of our life. Let us do an activity. Collect some samples of soil from different places such as a garden, roadside and construction site. Examine these samples under a magnifying glass. You will learn that the garden soil contains grass, ants, etc. Roadside soil contains concrete, insects, etc. And soil from the construction site contains sand, concrete and cement. Composition of soil. About 1/5 of the area of the Earth's surface is covered with soil. The components of soil are water 25%, air 25%, mineral particles 45%, and organic matter like humus, roots, and organisms 5%. A vertical section through different layers of the soil is called the soil profile. Each layer differs in texture, color, depth, and chemical composition. These layers are referred to as horizons. The uppermost layer is generally dark in color as it is rich in humus and minerals. It is humus that makes the soil fertile and provides nutrients for growth. This layer is generally soft, porous, and can retain a lot of water. It is called the topsoil or the A horizon. The next layer has a lesser amount of humus but more of minerals. This layer is generally harder and more compact and is called the B horizon or the middle layer. The third layer is the C horizon, which is made up of small lumps or rocks with cracks and crevices. Below this layer is the bedrock, which is hard and difficult to dig with spade. Rocks get heated by the sun and cooled by the rain continuously for many years. The surface rocks break down into small pieces because of repeated heating and cooling. These small pieces are carried to different places by wind or rainwater. As they move, they get mixed with organic matter. These pieces rub against each other due to running water and become smaller and smaller as they move from one place to another. Thus, soil is formed. The rate of absorption of water is different in different types of soils. This phenomena of absorption of water by soil is termed as percolation. Now let us do an activity. Take a hollow pipe having a diameter of 5 centimeters. Place the pipe about 2 centimeters deep in the ground. Pour 200 milliliter of water in the pipe slowly. Note the time when you start pouring water. When all the water has percolated, leaving the pipe empty, note the time again. Be careful not to let the water spill over or run down on the outside of the pipe while pouring. Calculate the rate of percolation by using the following formula. Percolation rate milliliter upon minutes is equal to amount of water in milliliters upon percolation time in minutes. Soil contains moisture. Let us do an activity to show this. Take a boiling tube. Put 2 spoonfuls of soil sample in it. Heat it and observe it. You will observe that the soil evaporates, moves up on heating, and condenses on the cooler inner wall of the upper part of the boiling tube. Different types of soils absorb water to different extents. Let us do an activity to show this. Take a plastic funnel. Take a filter paper or a piece of newspaper sheet, fold and place it as shown here. Pour powdered soil into the funnel. Measure a certain amount of water in a measuring cylinder and pour it drop by drop on the soil. Do not let all the water fall at one spot. Pour water all over the soil. Keep pouring the water till it starts dripping. Subtract the amount of water left in the measuring cylinder from the amount you started with. This is the amount of water retained by the soil. Calculate the weight of soil after it has absorbed the water. Weight of soil is equal to 50 grams. Initial volume of water in the measuring cylinder is equal to 10 milliliter. Final volume of water in the measuring cylinder is equal to 5 milliliter. Percentage of water absorbed is equal to 10 minus 5 upon 50 into 100 is equal to 10%. Take small amount of sandy soil, loamy soil and clay soil on a sheet of white paper. Examine these under a magnifying glass. You will observe that sandy soil is made of sand particles which are relatively large in size. They cannot fit closely together and there is large space between them. This space is filled with air. If the amount of large and fine particles is about the same, then the soil is called loamy. In clayey soil, fine particles are relatively high in proportion and have very less space between them. Sandy soil is made of a greater proportion of big particles. There is large spaces between them. This space is filled with air. This soil is light, well aerated and dry. It is grey or brown in color and rich in organic matter. Clayey soil has small-sized particles and water can be trapped in the tiny gaps between them. Hence, clay soil is heavy and holds more water. It is used for making pots and toys. Loamy soil is a mixture of sand, soil and silt. It also contains humus and is therefore considered the best for the growth of plants. That is why it is found in gardens and farmlands. Collect samples of clay, loamy and sandy soil. Take a fistful of soil from one of the samples. Remove any pebbles, rocks or grass blades from it. Now add water to it drop by drop and knead the soil. Add just enough water so that a ball can be made from it, but at the same time it should not be sticky. Make a ball from this soil. Now try making a ring from this ball. Repeat this activity with other samples also. From this activity you will find that only clay soil is suitable for making toys and pots.